Hi, everyone. Thanks for joining us again for another podcast. Today we have a factory applications engineer, Calvin Pitman, who works with our power and isolation products. Today he's going to give us a quick overview of our digital isolators. How are you doing today, Calvin?
Pretty good, Isaac. Thanks for having me.
Hey, thanks for joining us. So right off the bat, what are the key features of our digital isolators? I guess, is that mostly our SI86XX family?
Yeah, that's our SI86XX family. The SI86XX family of digital isolators, they use very low power. They pass a digital signal from the input to the output of the device and have up to 5 kilovolts of isolation. We have OPNs that have 10 kV surge capability, which are SI86XXT devices. And then we have SI8600 devices that are actually bidirectional to support isolated I2C. These digital isolators are used in a lot for isolated communication between two different systems in an application. We also have LED emulators, which are SI87XX devices, which are drop-in replacements for optocouplers.
Can you go ahead and summarize some of the types of customer applications that we see our digital isolators being designed into?
Yeah, these isolators are designed into a very wide range of applications. In the automotive industry, these isolators are commonly used in battery management systems and for isolated communications. In the industrial space, we're in automation systems, motor control, data acquisition. We're in power supplies, and we're getting more traction in consumer lighting applications as well.
I'd like to think that Silicon Labs is one of the only people who provide digital isolators, but what are some of the main parameters that customers should take note of when viewing our isolators? I guess, what are our most prominent parameters that make Silicon Labs look good?
Yeah, there are a few key parameters for our SI86 family that I'd like to highlight. First, the speed of our digital isolators. The SI86XX channels support data rates up to 150 megabits per second. The propagation delay of our digital isolators is a maximum of 13 nanoseconds, which is the best in the industry. Another key feature of our digital isolators is our high transient immunity. These devices are very robust against transient voltages and noise. Current generation SI86XX devices have a minimum CMTI of 60 kV per microsecond, and our next generation devices are going to increase that up to 150 kV per microsecond. So we're very robust, and we are great in that aspect as well.
Great. So when customers are using these parts, what are some common design issues that they typically run into? What kind of supporting documentation can we also provide them?
Yeah, sure. One of the main issues that customers might see is that they'll see parts getting damaged due to electrical overstress events. A lot of the time, the reason for this is just that they're not paying careful attention to the absolute maximum table in the datasheet. If they're able to adjust their design to meet these specs, that's great. If they can't find some over voltage or over current event that might be causing the issue, they can add protection to the device, such as a TVS diode on the supply, low series resistors on all of the pins, and that'll just help those resistors connect as cheap fuses to protect the part. We do actually have an app note with some guidelines for this, which is AN583. Another big customer issue is EMI. Especially in the automotive industry, this is a really important spec for customers. One way to reduce these emissions is by improving the layout, specifically with capacitor placement. Customers can put caps close to the device VDD and GND pins. So by moving that bypass cap as close to the VDD and GND pins, that can really help with emissions. They can also add a Y1 cap or make a PCB capacitor by putting some overlap of the inner VDD-A plane and the GND-A plane. So adding that Y1 cap in between the grounds kind of helps cancel out some of those emissions. It's a bit difficult to describe without a picture, but actually we just released an app note on this a few weeks ago, AN1131, which is our design guide for reducing radiated emissions. This app note goes into a lot more detail and has a lot of other really good ways to reduce emissions. It's a brand new app note, and it's a great resource for customers.
Thanks. Those are great tips and great resources to point customers to. Well, Calvin, that's all the time we have today. I want to thank you again for giving us this overview over digital isolators, and Thanks again for your time.
Yeah, thank you, Isaac.